Okay, so welcome back, and now we're going to do another example, and we're going to do this one. Now, notice it has the square root of a squared minus x squared in here, but now at first glance we might be able to do a u substitution, right? Where we could make u equal this, and then du would equal x. And so because we've got an x here, but the problem is x is in the denominator. So we can't do that, and the dx is in the numerator, so we can't do a u substitution, so we're going to have to do a trig substitution. So again, because it's in the form of ax squared minus x squared, we're going to use the substitution of x equals a sine x. A in this case is 2, so we're going to do 2 sine theta, or sine theta equals x over 2. And so again, if we draw our reference triangle, which I highly recommend that you do, now what do we get? We get, now again, the more you do these, the more you're going to get familiar with these, and you can fill these in very quickly. So this is going to be x, 2, and the square root of x squared. So 4 minus x squared. Okay, so now let's do our substitution, and then we're going to come back to this when we go at the end. Okay, so now let's do our substitution. Okay, so x equals this, and then of course dx equals 2 cosine theta d theta. Okay, so let's write this. And so this is going to be the square root of 4 minus, 2 sine theta squared over, now, the x here. Okay? We're going to put 2 sine theta here for x, right? And then the dx is going to be 2 cosine theta d theta. Okay, so now it looks like a lot going on. Okay, so let's simplify this. Okay, so we get the integral, and we get 4 minus 4 sine squared theta, and we get 2 cosine theta d theta over 2 sine theta. Okay, so now I'm gonna, because I don't have a lot of room, so I'm gonna do steps. So I know I'm gonna factor out the 4, and so I'm going to get the square root of 4 times 1 minus sine squared theta. So we already know where this is going, right? So again, we see how this is going to break down on the top. Okay, so what do we get? So this is going to give us 2 times 1 minus sine squared theta times 2, so this is going to become a 4, times cosine theta over 2 sine theta d theta. So this 2 is going to cancel with this 4. So 4 divided by 2 is 2. So we're going to get 2 up here. Okay, now this is going to become the square root of cosine squared theta, right? And again, the square root of cosine squared theta is just going to give us cosine theta, right? So this is going to give us 2 cosine theta times cosine theta over sine theta d theta. Okay, and now this becomes 2 cosine squared theta over sine theta d theta. Okay, so now we've got cosine in the numerator and we got sine in the denominator. Okay, we can't do a u substitution in this case because if we make u, we can't make cosine u equal to cosine because then we get again du in the bottom. Okay, or we get 1 over sine, which isn't going to work. Okay, so let's do this a different way. Let's do the substitution, okay, of the Pythagorean theorem and see what happens here. Because again, there's really nothing we can do with this the way it is. I mean, I'd love to do a u substitution at this point, but it's not. If it was the other way around, if sine was on top, then yeah, we would be able to do it. But it's that cosine squared that's messing it up. So let's just see. Let's do the Pythagorean identity and see what happens here. So we do 2 times 1 minus sine squared theta over sine theta d theta. And then let's break this up into 2 fractions. So we're going to get 2 over sine theta minus 2. Now this is where the sine squared theta and is going to cancel with one of the sine squared, or let me rephrase that. The sine theta is going to cancel with one of the sine one of the sine thetas up here. So that's going to give us 2 sine theta. So we get this, right? Okay. So we got a 1 over sine theta in the first integral, or in the first term. Okay. Well, what is 1 over sine? Well, we don't want to leave it this way again. So let's see. We can do 1 over sine. What's 1 over sine? That's cosecant, right? So let's write this as the integral of 2 cosecant theta d theta. Right? We could split this up into 2 integrals if you want. It doesn't matter. I mean, we're going to do it term by term anyway. So we get 2 cosine squared theta d theta minus 2 sine theta d theta. Okay? And so now we've got 2 functions that we should know how to integrate. Okay, this is where your knowledge of the integrals come in. Okay? So, cosecant gives us the natural log of cosecant minus cotangent. So remember, secant, no, not secant, but Yeah, secant, remember, is secant plus tangent. So cosecant, we're going to get something similar to that. So it's going to be the natural log of cosecant theta minus cotangent theta. Okay, and then of course, the antiderivative of sine is negative cosine. So we're going to get a plus here. Okay, so let's do that. Let me erase this. Okay, so now the integral of this is going to be 2 times the natural log of the absolute value, and since we're dealing with cosecant here, it's going to be cosecant, not cosecant. Oh yes it is. Cosecant theta minus cotangent, because before, if this was secant theta, and we're taking the integral of secant theta, it would be the natural log of the absolute value of secant theta, what? Minus tangent theta. Or no, it's plus, I'm sorry, it's plus. It's secant theta plus cotangent theta. Or tangent theta. But since we're dealing with cosecant theta, then remember, again, it's very similar to it, so it's going to be the natural log of the absolute value of cosecant theta minus cotangent theta is going to be the integral. Okay, so that's this piece. Now this piece is going to be plus 2 cosine theta plus c. Now, be careful, we're not done yet. Okay, so we integrated everything, but this is in terms of theta. We need to put it in terms of x. So this is where our reference triangle comes in again. Okay, so now we got to go back and we got to put everything in terms of x. So let's do that. Okay, so cosecant theta. Okay, so what? Oops, forgot. Here's my reference angle. Okay, so what is cosecant theta? Well, cosecant, remember, is 1 over sine, right? So what's 1 over sine? It's the reciprocal of what you would get for sine. Well, sine is this over this, so cosecant would be, oops, that, right? Makes sense? So all I'm doing is just applying the definition. Oh, gosh darn it. I said 1 over sine and I wrote down cosine. This over this. There we go. Sorry about that. So again, 1 over sine. I went to here for some reason. I don't know why I did that. Maybe I was thinking of the cotangent. But anyway, so it's 1 over sine, so it's a reciprocal of sine. So sine is x over 2, so this would be 2 over x. Keep going. Not x over 2. 2 over x. There we go. Sorry about that. I haven't had my coffee yet this morning. Okay. So again, cosecant, just to clear up everything, cosecant theta is 1 over sine theta. Sine theta is opposite over hypotenuse, so cosecant is hypotenuse over opposite, which is this. Okay, so there we go. Now minus cotangent. Well, cotangent is 1 over tangent. right? So tangent is what? Opposite over adjacent. So this is x over this. So cotangent would be this over this. So minus 4 minus x squared over x. And so we're done with that. Okay? Now let's go to this one. Now cosine is what? Adjacent over hypotenuse. So this over this. So it's going to be 4 minus x squared over 2 plus c. And so now at this point, now let's simplify. Okay? So now I wouldn't simplify the first one. I would just leave it like that. I wouldn't combine it and have 2 minus the radical on the numerator. I mean, you can if you want, but there's no need to. So we can leave this one alone, just leave it as 2 fractions. But this one, obviously, we can cancel this. So then our final answer could be this. Now, realize that there are going to come times where you're going to be able to simplify this even more, okay? But we'll get to those. Okay, and that's the final answer. That's it. So again, same process that we did before. Just make sure you take your time and just take your time, okay? So we're going to do another example, and this one's going to involve 2 different methods of solving, okay? So we'll talk about that next, but again, so here's another one. The next one, I'm going to show you 2 different ways of solving these, okay? Like I said, there's sometimes more than one way of solving these.